when you look at, connections, there's this tendency to think that all connections to HSS are difficult. Sometimes there are certain connections that can be difficult, but for a lot of simple connections, for example, just a beam to a column, a shear connection, you really can do exactly what you're doing for the vast majority of connections to wide flange columns. Just weld a single shear plate on there and be done with it. In some cases it's actually easier, right? Because you don't have to deal with any web connections because there aren't any webs. Dealing with that aspect and making sure that engineers know that it's not really as hard as it's gotten a reputation to be is certainly an important part of what this engineering team has been doing. One type of connection where we're seeing a lot of innovation is with braces, actually. And braces are one of those member types where HSS makes a lot of sense and has been used quite widely. But there are some aspects to actually making the brace connections where there's an opportunity for improvement. And so one thing we're seeing now is a lot more use of cast connections, where aside from elaborate projects with custom castings, you're actually now seeing some off-the-shelf castings that are easy to fabricate in the shop and then very simple to actually connect in the field. And so it's taking what has been, traditionally already a pretty strong HSS use case, because braces tend to be longer and more lightly loaded than columns, and it's making it that much easier by taking away any difficulties associated with that connection.
And I think some of the innovation that comes from the connection is Atlas identifying the companies out there that are doing some of the innovation that obviously plays well with us. Whether it be a company like Cast Connects, which is doing some of the castings that Ted referred to, or some of the other single-sided bolt companies that are out there. Another industry out there that's just kind of a burgeoning now, and it's the additive manufacturing. And so, working with the casting companies to get into, how are they taking advantage of additive manufacturing? How can we be involved with that to simplify the way our product is used?
Another development we're seeing in the industry that's really helpful from an HSS design standpoint is, people are using more and more finite element analysis for connections. For wide flange connections, there's this huge volume of research and guidance that's been published, so that if you have, wide flange or, similar type of rolled shape, and you've got some force coming into it from an odd direction, an odd location, there's probably some reference that you can look into that's going to give you design guidelines for how to make that connection. Because HSS has not been around as long as rolled shapes and has not been used quite as much, that volume of research is smaller. And so with finite element modeling programs, you don't need to have that specific configuration that maybe there's an equation for in the manual. You can basically build what makes sense based on the loading and know that you're going to get, a accurate analysis of that. And so there are a lot of, really kind of common sense things that you can do. For example, if the wall of the HSS is failing under a connection load, well, add a thicker plate there to reinforce it. That's a really basic thing to do, but up until now there hasn't been necessarily the code equations for an engineer to actually analyze it. And if you can't analyze it, you're probably not going to tell someone to build it. So the availability of these modeling programs, specifically I think Idea Statica is probably the best known one, it allows people to actually make use of what are really common sense solutions in their HSS connection design.
So people don't realize is they have tools at their disposal now, because they come to us and say, well, we don't really evaluate HSS because it takes more time. There are programs out there that actually you can do direct comparison between a wide flange and an HSS column within the software. You have design groups that you pick within the software, and it actually gives you a comparison. And so it's about understanding the tools that you already have and how to take advantage of those to actually do some of these comparisons that we talk to people about. We're not asking you to do any extra work. It's just taking that extra time to maybe do an extra design group within your software and actually do a direct comparison between how the wide flange would perform in your building versus how the HSS would perform.
And I think there's almost a little bit of a cycle where, an unfortunate cycle where engineers are not exposed to the same amount of education when it comes to designing HSS, and specifically the connections. And so often the connection design is not as efficient as it could be, which means that when the fabricator gets the project and they have to price those designs, they may end up at really a higher number than they should be. And so it kind of feeds this perception that HSS is a really expensive product to use in general. But if you're using best practices and designing the connections, something we're perfectly happy to help you do, then you're going to end up with something that, from an overall cost standpoint, is much more competitive than what a lot of engineers, I think, have come to expect. One of the best examples of where there's maybe some misconceptions about designing with HSS is when you come to shear connections. There are a lot of engineering companies, very highly regarded engineering companies, even the company that I used to work at before I really dove into the HSS world, where the standard shear connection for a beam to an HSS column is a through plate. And that's a very expensive detail to fabricate, especially if you have beams coming in from two directions. Now you have plates crossing in the middle of the column. You have to cut the column open to install these, and it adds a lot of cost. When in reality, a simple shear connection where you just weld it to the face of the column is going to work most of the time. So I think, if at the end of my career with Atlas, I've managed to get those through plate details off of, engineers' typical detail sheets, I will consider my life's work a success.